In this video we're going to look at how we can use equations to describe the oxidant and the reductant. Remember the acronym oil rig. Oxidation is loss of electrons, reduction is gain of electrons. We can use these rules to determine the oxidation numbers in a given equation and therefore work out what is the oxidant and what is the reductant. So if we take the equation 2 mg plus O2 goes to make MgO, and there'll be two of those if we balance that correctly, then we can put the oxidation numbers of the different substances in this equation. Magnesium is an element, therefore it's got an oxidation number of 0. Oxygen is in its elemental form, therefore it has an oxidation number of 0. On the right hand side, oxygen in an oxide from the rules has an oxidation number of -2. Therefore, to keep the whole charge as 0, magnesium must have an oxidation number of +2. If we then join each of the substances with each other, we were to join magnesium with magnesium, and then we were to join oxygen with the oxygen, we can see that magnesium is moving from oxidation state 0 to +2. It's increasing in its oxidation number, therefore it's oxidized. Oxygen is moving from oxidation state 0 to oxidation state -2. That means to say that oxygen is being reduced as its oxidation number is going down. Because the magnesium is undergoing oxidation, the substance that's oxidizing the magnesium is the oxygen. This means to say that O2 is the oxidant. Oxygen is undergoing reduction. The substance that's causing the oxygen to be reduced is the magnesium. This means that magnesium is our reductant. If a species undergoes oxidation, it's the reductant. If a species undergoes reduction, it's the oxidant. In more complex reactions, such as the reaction between the permanganate ion and iron 2 in acidic conditions, we have to work out the oxidation state of all the species so that we can discover which species is oxidized and which species is reduced. So we assign oxidation numbers to the species. For example, with the permanganate ion, we know that oxygen is -2, -8 in total, as there are 4 oxygens. Therefore, the permanganate, as it needs an overall negative charge, must be +7. The manganese ion on the right hand side has an oxidation state of +2. This is its charge. The hydrogen ion has an oxidation state of +1, as it's a monatomic ion with the charge +1. And the iron ion has an oxidation state of +2, as it is a monatomic ion. On the right hand side, the iron ion, so iron 3, has an oxidation state of +3. And then with the water, oxygen has an oxidation state of -2. Hydrogen is +1, and there are 2 of them, so +2, but originally it was +1. We then need to look at the species that have changed. The manganese ion has decreased in oxidation number from +7 to +2. It's gained electrons, and reduction is gain, that has been reduced. The iron 2 ion has increased in oxidation number. It's lost electrons, so that must have been oxidation. If you remember from earlier, The substance that is reduced is the oxidizing agent. So in this example, the permanganate ion is the oxidant as it's been reduced. The hydrogen and the oxygen don't change oxidation state. Therefore, the reductant must be the iron 2 ion. It's important to note when quoting an oxidant or a reductant you must give the full chemical formula, as the manganese itself is attached to the oxygen.